Welcome back to NCRT class 9th, chapter number 8, motion. Children, in our previous class, we studied an introduction about motion. There we came to know what is the meaning of a motion and certain examples we have taken, and also we studied how to describe a motion in detail. Means we need to know the position, all such things we came to know in our introduction class. So children, with this previous knowledge, in today's class we are moving with another topic of this chapter, that is what? Describing motion. Describing motion. Children, I already told that there are mainly two important terms which we need to understand in order to motion. The main two physical quantities are very important in order to understand the motion concept. So what are those? The first one is distance, and it is also sometimes called as a path length. What it is called, children? Path length. The another quantity, that is what? Displacement. With these two quantities, we are going to know motion in a precise way, children. It means that we need to know the meanings and definitions of these. Then only the motion concept is becoming easy to us. So what is this distance and a displacement? Distance is nothing but a children, it is the length covered by an object from one position to another position. Understanding my point? It is nothing but it is the length, how much length an object has covered. For example, a car is traveling from home to school. So whatever the length, whatever the path it has covered from home to school, then it is called as a distance. So we can say that a distance is nothing but a total path or length covered by an object from initial position to final position. You know, children, the meaning of a initial position and a final position. Position means we already know. It is nothing but a point where an object is located. Here, initial position means the beginning point or starting point you can consider, children. For example, as I told, a car is traveling from home to school. Here, where it is starting, where it is beginning, where it starts to move, that is from the home. So home is taken here now as a initial point. Any object, if it is moving from one place to another place or from one point to another point, it will be having a position, children. The beginning point is called as a initial position. It is also sometimes called as a initial point, no doubt in that. And the end point where it is going to stop, isn't it, children? It is moving from home and to where? Up to school. After reaching the school, it is becoming again stationary. There means destination has reached. So that school, that point is called as now final position. So once again I'll repeat, children, the definition of a distance says that how much length or path it has covered from initial position to final position, and it is called what? Distance. And it is also called sometimes what? Path length. Got it, children? Okay. Now then what is mean by displacement? We want to know the another quantity definition, no? It is a simple, children. It is nothing but it is the shortest path, isn't it? It is the shortest path an object travel between the initial position to final position. Shortest path covered by an object between initial position and final position. So, let me explain these two quantities with an example, children. Let us take an example. A boy is here. That is, this point, we'll name it as a home. From home to, he is moving to school. This is what? School. Let us imagine that a person, nothing but a boy, is traveling from home to school, and then he travels to shop. That is, it might be an ice cream shop. Ice cream shop. He traveled. So what is this? Let me name this better. This is a home, is a what? It's a point, initial point. We call it as a initial point. And school, he'll travel. Then from school to, that is what? Ice cream shop. This is B and this is C, because he is moving from a initial point A to B point, nothing but a school, and from school to, he is going to ice cream. So the total distance, nothing but a total path of what he has covered, children, here, that is distance here is, we can write, this is what? This length can be written as a AB. Shall we write like this? This distance is what? We don't know, no? We can name them with the quantities, that is BC. This is the total distance covered by this boy. Then what about the displacement? It is nothing but a shortest path. Means from home to ice cream, the path is very shortest, isn't it? So this is the what? Shortest path. Now the displacement is what? AC is the shortest path, irrespective of how he is going and reaching the destination. But here we need to consider the shortest path, that is called as a displacement. I hope with this you are clear, isn't it? With the concepts like distance and a displacement. Always keep in mind, distance is nothing but it is a total length covered by an object from one point to another point, whereas displacement is nothing but a shortest path covered by an object between the initial position and the final position. Now children, we will describe this, that is motion along straight line. Children, motion along a straight line. As I already told, motion can take any pattern. Means it might be moved in a straight line, it can take a path of circular, it can be in the form of a oscillatory. Like that, a motion can take a different patterns. In this chapter, we are studying with a simple and easiest pattern or path, children, that is motion along a straight line. Means if an object moves in a straight way, then at that time, what are the distance and the displacements we are going to study here. And this can be studied by using a presentations, nothing but a straight line presentations. Let us take, children. We'll draw a line from this point to this point. This is what? The path or the straight line where an object travels from one point to another. Is it straight now, children? Okay. And this point we'll name it as a O. Always remember, children, any movement or any beginning, it will be having some reference point. We'll call it as a origin or a reference point or beginning point. So here O is the reference point or origin, you can say. At this, it will be not stationary, isn't it? So we'll take it as a 0, and here all in this axis, let us take a timings, children. Sorry, kilometers we'll consider. That is what? Kilometers we'll take. Here 5, then 10, 15 kilometers, 20, 25, 30, 35, 40, 45, 50, 55, 60, then 65. So here, this is a straight line. An object is traveling in this path in a straight way. So let us take, this is a car. If a car travels from O point to A point at 60 kilometers, up to where it is traveling, children? From 0 to 60. Let us mark this point as A. Here, first how it travels, children? From 0 to first, it will goes to C point. And then here, let us take at 35 B point. The total, how it is moving? First, it travels from the origin point to up to 60 kilometers and moves back to what? B point, and from B to it moves to C point. Understanding, children? For each unit 5 difference we are having here. How much kilometer difference we have? For each unit we have with the 5 units here. So in this case, what is the path length or distance, children? The total distance from initial point to final point. OA is the total distance, nothing but 60 kilometers, isn't it? Now, here mainly two things, means two cases we need to understand. That is first case or case number 1. If distance is equals to displacement. The case 1, what it says? What will happen if distance is equals to displacement? Let us take here, that is distance, children, first. Let us take a distance from point O to A. How many kilometers is there? 60 kilometer. So shall we take it as a 60 kilometers? Isn't it, children? Then it moves back to how much? That is S, that is displacement. We will leave that. And here the displacement is also becomes a 60 kilometers. Because this is the initial point, this is the final point. The shortest path is what? The same. So the displacement also what? 60 kilometer. So for this, how we can write? That is 60 is equals to 60. So the distance can become equal to displacement is valid here. And in the next case, case number 2. Sorry. Distance cannot become 0, but displacement can become 0. Understanding, children? What is the meaning here? Distance is some numerical value we are going to get, but displacement we can get in that case 0. Let us take the same example here. Let us take here better. An object is moving from O to A, and again it goes to B and it goes to C. Isn't it, children? So first here, what is our distance value? That is, the total distance is 60. Then here 60. Let me write better. Distance is how much, children? OA plus, that is AB plus AC is the total distance. Here, what is the OA value? 60 plus AB, 5, 10, 15, 20, 25 plus BC. This is not AC, sorry, BC, isn't it? 5 and 5, 10. 60 plus 25, how much, children? 85. 85 plus 10, 95 kilometer is the distance. Isn't it? So, next here, the displacement. See children, here it is moving from O to A and B it goes, and B to C it travels, and it goes back to C position. Then at this time the displacement value will be 0. What it is doing? First it travels from here to here and it goes back to the same point. Here the initial point and the final point are coinciding, means same. At the same point we are getting a initial position value and a final position value. So what will be our value of a displacement? 0. Here 60 kilometers. Or you can take here also, that is displacements, you may get nearly 120. It means that in the two cases that is displacement, distance can be equal to displacement, and here in the second case distance cannot be equal to 0 but displacement can become equal to 0. It means that these two physical quantities are helpful in understanding a motion, children. Is it clear, the concepts? Yes. In today's class, children, we studied distance means what and displacement means what, and also we studied motion along a straight line.